Hi everybody, it's Mrs. Peachy, your WCA Physical Science teacher, and today we are going to be doing a lab tutorial for the portfolio on momentum. This is Unit 1, Lesson 7. So what you're going to be looking at is two different types of collisions, inelastic and elastic collisions, and you're also going to be looking at the law of conservation of momentum. Okay? So you'll be doing an online simulator here, and it starts like on page 3, I think slide 3 of your lesson viewer. And so there are two different parts of this. There's day 1 and day 2. I am just going to have you do and submit day 1 for me. So, you do not have to do day 2, and you do not need to submit that into the Dropbox, okay? So that is hopefully something that you guys will get so that I don't get a whole bunch of copies of day 2. Day 1 is long enough as it is. So when you open day 1, this is going to bring you to a PDF document right here. And I know some of you are new this semester, so let me walk you through what you need to do with this PDF. What you don't want to do is scroll down and just type right in the boxes. As many people who have been here a while will tell you, that is just wasting your time, because what's going to happen is that nothing will get saved and you'll end up submitting this document to me. You'll think it's done and it will be blank and I won't be able to grade it and you'll have to do it over. So we don't want that to happen. So what I want you to do is to right click on it. Try that again. Okay, so we're going to select Save As. And when you save it, you need to then kind of save it to your computer. I would advise saving it to the desktop, but some people like to save them in different locations. Close this window here, and then reopen from the desktop. Then when you type in it, you should save again before you attach it to your Dropbox, because that will ensure that I get a complete PDF, okay? So we are looking at two different types of collisions. Momentum is defined as mass times velocity. So it is a property of motion, okay? But it makes more sense to talk about momentum in terms of two objects colliding than it does to just talk about it with one object in motion. One thing, the bottom line is that if an object is not moving, it does not have momentum. So there has to be velocity involved, okay? The other thing that's true is that momentum is conserved in a collision. Now, that doesn't mean that if this object is going to collide with another object, say the desk, that the momentum of this object is going to be exactly the same before the collision and after the collision. What it looks at is the entire system. If two objects collide, both of their momentums will change, but where one may have a decrease in momentum, the other one may have a corresponding increase in momentum. So they kind of balance each other out. And that's the ideal situation, that momentum would be conserved. That's the law of conservation of momentum, okay? In reality, what we oftentimes see is we see collisions that are neither perfectly elastic or perfectly inelastic. We're going to see collisions that kind of fall somewhere in between. Because in reality, we do have some velocity and stuff lost due to friction, due to heat from the collision, the deformity of the materials and stuff like that. So the real world is much more complex than what we make it out to be on paper sometimes. So in this lab, you're going to collide two objects. You have some equations here. M1, V1, M2, V2. M1 refers to the mass of the first object. V1, the mass or the velocity of the first object. M2, the mass of the second object. V2, the velocity of the second object. Then you have in parentheses initial, final, final. Because prior to the collision, they're going to have a certain velocity. After the collision, they're going to have a different velocity, mass shouldn't change unless for some reason something blew off, but we're just going to go mass does not change before and after the collision. And so you should set those equal to each other because, again, this goes along with the law of conservation of momentum. So to define the difference between elastic and inelastic collisions, perfectly elastic collision would be like dropping a ball. Now this is horrible because I couldn't find a ball, so I'm using a little apple. So this is not going to work out real well. But if you drop a ball and on the desk and it bounces, that's an elastic collision. However, the only way it would be perfectly elastic is if it would hit and bounce back to the same height that it was dropped from. Okay, so then a perfectly elastic collision would not lose any of its kinetic energy. That doesn't happen in real life at all. Okay, you can get things that are pretty close to perfectly elastic collisions, but you don't get things that are exactly perfectly elastic. A perfectly inelastic collision would occur when, if you have two objects that are kind of colliding, I guess. Let's say this first object is not moving, it's just sitting there, so it has no momentum. The second object hits the first object and transfers all of its energy to the second object. So basically, in that case, you get a complete transfer of kinetic energy. That would be perfectly inelastic collision. But you're not going to, have either one occur in real life exactly that way. But, you can get pretty close to them. However, in the simulations, you can get both of these guys to occur. Okay? So going back to our lesson viewer, we're going to click on the virtual momentum lab at the bottom. It's going to take you to the sim. Well, it takes you to this page, and then you click go to lab, then you click simulation, proceed, and then you get to just select whether you're going to do perfectly elastic or perfectly inelastic, and it will tell you that in the directions, so I'm not really going to go through that part with you. We're going to look at perfectly elastic for now. You get to adjust the masses, and it will also tell you, what factor to put the elasticity at. Was that masses? That may have been velocities on the last one. Okay. So, what you're looking at here is you look at a demo. It'll actually collide. Let's see that. We got to give it some sort of a... Oh, we didn't put the ball on the table. Okay. Here. Follow directions, Mrs. Peachy, right? I'm trying to go quickly because of my time here. The directions are on the side, people. Okay. Place the balls on the table. Move the slider to set the velocity. So we're going to give this guy a starting velocity of, I don't know. I'm going to do 2. Come on. Don't know if I can get 2 on the button. Really? Well, maybe not. And then begin the experiment. I want the second ball to be, I don't know. We'll go -2. Do y'all realize why we have positives and negatives here? Okay. You might think negative velocity means it's slowing down. The negative velocity does not indicate things are slowing, but just going in a different direction. So if something is moving, toward the table, we'll call that positive velocity, and then when it bounces up, we can call it negative velocity. Although oftentimes when you're doing it this way, down means negative and up means positive. It's just about a frame of reference, and you have to decide that frame of reference, but it has been decided on here that going to the right is positive, going to the left is negative. So then when we collide these guys, it kind of shows the behavior, but what you're going to see over to the right is you're going to see a graph of the velocities. You're going to see the after velocities as well. And then you're also going to see a graph of the momentum, and I think that's kind of one of the more important pieces here. It's when you're going to be answering your questions, okay? So that pretty much gives you the gist of what you're going to be doing on this portfolio. You're going to do some elastic collisions and some inelastic collisions. You're going to make some predictions, And you're also going to be answering some follow-up questions. Make sure you put some detail in those follow-up questions, okay? And really demonstrate to me that you understand the law of conservation of momentum. If you have any questions or concerns, feel free to give me a call at extension 2204, or you can send me a webmail message.